Hi, good morning. Welcome to the last day of Ignite. We're here to talk to you today about Windows and Linux and everything in between, including the Windows subsystem for Linux. My name is Craig Lowen. I'm a program manager working on the Windows subsystem for Linux, or WSL. And I am joined today by
Sven Groot, and I am a developer on the Windows subsystem for Linux. Thank you all for coming so early on the last day, especially after the event yesterday.
Yeah, we really appreciate you coming out. So we're going over the modern Windows command line, all about the Windows subsystem for Linux and the Windows subsystem for Linux 2, which is the latest and greatest in Linux tools on Windows. So the first thing we want to talk about is Microsoft and Linux. That's kind of interesting, right? We have the Windows operating system. Why are two folks from Microsoft here to talk to you about the Linux operating system as well? And really, there's something that you should be really familiar with, and if you haven't heard of it, you might be in the wrong conference, and that is Azure. Azure has tons of cloud hosting opportunities, and a lot of them use Linux servers. And I'm sure if you're interacting with the cloud and servers or any application hosting in general, you're already familiar with the Linux environment. But beyond just Azure and servers, we also have other exciting opportunities for Linux here at Microsoft. If you have not seen the new device, the Microsoft Surface Duo, it is a dual-screen device coming to stores in holidays 2020, and it actually uses the Android operating system. So this device here, produced and sold by Microsoft, will be using the Linux operating system. So Linux is becoming more of a player in the tech landscape, and we want to make sure that you and all the users in your organization are empowered to use Linux tools on your Windows machines. And that is where the Windows subsystem for Linux, again, WSL to save some time, comes in. So we at Microsoft really do love Linux. And WSL allows you to run your favorite Linux tools, command line tools, utilities, applications, all directly on Windows unmodified. And that means any L64 Linux binary will run inside of this subsystem. And so what this means is if you have users in your organization or you yourself love Windows, you are now able to use the whole wide world of Linux. So if you've ever gone and tried to install something like Ruby on Rails, and you look up a tutorial online, and you see a bash script right away, and you go, OK, time to find the next tutorial, you can just open up a WSL window, get started with bash right away, install it, and run that application. And on the other hand, if you're someone who loves Linux, maybe you're a really big fan of Linux tools, Linux workflows, came from a Linux background, and now you're using a Windows machine, well, you can open up a bash shell, start using that right away, and more importantly, still have access to all of the tools and ecosystem and utilities that Windows has to provide, such as things like Microsoft Office and Photoshop, all on the same machine. So I can talk to you about WSL for a long time, but I think it'd be better to show you what exactly that looks like with a demo. So we'll switch over to my machine. So here we are. So this is my computer. And what you might have seen normally is you can go to the Start menu and open up Ubuntu straight from my Start menu. And this opens up in the classic look for the Windows command line.
That's kind of old, isn't it?
Yes, it hasn't been changed in a while. And that's why we're going to be using the new Windows terminal today. And so this is an app that we have. You can see it right on the bottom of our screen. And it has a gorgeous new interface for all of your command line utilities and applications. So here we are starting in PowerShell. But if I go to this drop-down menu, I can actually select all of my different Linux applications from here. So I can select my different shells. I can open up Ubuntu. I also have Debian installed here as well. And when I go and open these, I get a totally different theme. I can have acrylic fluent backgrounds where I can see through. I can even have background images. So we're moving the command line across all of Microsoft to really make it a much better experience for you. So please check out Windows Terminal. And so this is the bash shell. And so you can see that I'll start off inside of my Linux root directory, and I'll do interesting Linux tools, like I can run sudo apt update. So I have access to a package manager. And I can also do things like run Python. And so here you can see that it's actually running as a Linux 2. So what that means is when I import my system application and run sys.platform, I get Linux 2. This means we're running an actual Linux binary. Python sees itself as running on Linux because it is.
So you don't have to cross-compile anything.
Right. You can run it directly as your Linux binaries straight from this prompt. And where we go beyond just a traditional VM experience or a traditional dual booting experience is we also gave you access to your C drive. So it's under Mount, and I can go to C. And I can even open up, I have a C dev folder here. I can run ls inside of it, the Linux utility. I can even run explorer.exe dot, and I can invoke Windows executables straight from this bash shell as well. So here's File Explorer opening up straight from my Linux prompt. And so a real-world example of what a developer might use this for is I can go back to my Linux file system, and I have a website here. So this is just a simple Node.js website, and I'm going to start it up. And so now it's running backed entirely by Linux. So if I'm publishing this website to a Linux server in the cloud, then I am now running an environment that's very similar to my production environment, which will go a long way to reduce bugs and headaches for you. So I'm going to open up the new Edge, and I even have the new icon if you haven't seen it. So this is the new Edge running on Chromium. And I'm going to go to localhost 3000, and here's my website, which says press the button, and I do, and a cat turns it off. So there's our very important production website, working totally backed by Linux. And the very last step of this is how do you actually get this on your machine, and what does it look like to acquire this? I'm going to go back to my desktop, and from here I'm going to search turn Windows features on or off. So the Windows Subsystem for Linux is an optional feature inside of your machine, an optional component. If you go to the bottom, you'll see the Windows Subsystem for Linux here at the bottom. We're at W, so we're alphabetical. And all you need to do is give that a check mark. It will install the necessary bits on your computer. You'll need to restart. From there, you have the platform to run Linux distros installed. And you go to the Microsoft Store to actually install the Linux user space. So if you search Linux in the search bar, you'll get this page, and you can install a bunch of different distros that we have available.
That's not the only way that you can do that, though. You can also install distributions without using the store, which I'll be showing later.
Yep. So let's jump on back to our presentation. That's a very quick overview of what you can do with WSL and the general workflows that WSL enables. And so I really quickly want to step you through how this actually works. So when we enable the Windows Subsystem for Linux as an optional feature, we enable the bottom two boxes, WSL, or we enable the middle box, WSL. And so this is a translation layer. The actual Linux user space binaries are provided by their respective maintainers, so the ones that we showed in the store, like Debian, OpenSUSE, Ubuntu. And then these user space binaries, whenever they call into a system call, it goes to a translation layer and is actually fed to the Windows NT kernel. And so everything at the end of the day runs on top of the Windows stack. But there are lots of extra improvements that we have coming, and talking about what we have available now, Sven is going to be able to show us some of these different improvements.
All right, so of course, the big new thing that everybody wants to hear about is WSL2, where we're going to keep you in suspense for a little bit longer to talk about a few features that are already available right now. They're in the last version of Windows 1903. And I'm just going to show them to you. There's three things I'm going to show. The first is the ability to import and export your distributions, which means that you can export any distribution you have installed, make a backup of it, but you can also import any tar.gz file and use it as a distribution. The second is the ability to access your Linux file system from inside of Windows. And the third is a really cool feature called Visual Studio Code Remote, which basically has you run Visual Studio Code in Windows while it is running the thing you're working on inside of WSL, so you can really seamlessly build, run, and debug your Linux applications from Windows. But instead of talking about all those things, I am just going to show a quick demo.
Demo-heavy presentations are much better on a Friday morning, so we're happy to be jumping into the command line a lot. Here, I'll switch you over.
All right, so let's look at import and export first. So if you've used WSL before, you are probably familiar with the command line application WSL, which is what normally gets you into WSL. But it also has some options. And you can see we added import and export there. What that means is that, yeah, you can take any distribution that is running on your system right now and export it to a tar.gz file. If you want to mess with some stuff and you're not sure it's going to mess up your environment, you can make a backup. If you're releasing a version of an application and you want to make sure that you have the exact tools that you use to build that version somewhere else, then if you have them so you can use them later, then you can do that. And of course, you can import them to get them back. But that also means that if you get any tar.gz file from anywhere, that happens to contain a Linux file system, you can use that as a distribution rather than installing it from the store. And one of the cool ways of doing that is by using Docker. For example, if I go back into Ubuntu here and I will just run Docker to start a Alpine container. There we go. We are now inside of a Alpine container inside of Ubuntu on top of WSL. Can actually prove that that's where we are. There, it's Alpine 3.10.3. And you know what? I actually kind of like to have Git available, and it's not installed by default on Alpine, so I'm going to add that. And hoping the conference Wi-Fi is cooperating, which it seems like it is. So there we go. Now Git's installed here. And just exit out of that container. I'm back in Ubuntu now. And I can see the container I just created. There it is. So let me just export that container from Docker. Let's see, it's EFA. It's easier to type than confident Moser is the other way I could refer to it. Let's pipe that to gzip and just write that to the C drive because we're in WSL, so it can just go directly to Windows. And there we go. Alpine is nice and small, so that's really fast.
So we've taken the Linux user space of this Docker container, so all the user space that's in Alpine, we've put it into a zip tar file, is what we've done. And that's now stored on to your C drive.
Yes. So now I can go back over to PowerShell and invoke WSL.exe with the -- import option. Tell it I want to call this distribution Alpine. I want to store it in CWSL Alpine, and I want to import it from ctemp alpine tar.gz, which I just created. Even faster. Now if I list all of my distributions, we can see that Alpine has been added there, and I can start it like so. So now I'm back in Alpine in the exact same environment that I just had in the container. I even still have my command history, so I can show still Alpine, Git's still there. All the customizations I made to the container are now in WSL, but because it's now WSL, I can access my C drive. I can run Windows binaries. I can do all those things that WSL make possible. So this is a really cool way to get any distribution, including like CentOS or any others that may not be on the store, into WSL. All right, so the second thing I want to show is the ability to access your Linux files. Before, if you're familiar with WSL, we always kind of said like the files inside of your Linux distribution, we'd rather not have you try and touch those. But we have this very mission-critical website that Craig just showed, and it is sitting inside my my Linux file system. And it actually has a bug. Craig didn't say it, but what was supposed to happen is, because it's running on Linux, it was supposed to show a penguin flipper rather than a cat. It's a big mistake there. Can't have that going into production. And so because it's in the Linux file system, you'd think I'd be stuck using Vim or Emacs or whatever editor you prefer to edit the files here. But now I can actually do the same thing that Craig did earlier and run Explorer from here, open it in the current location, and it actually shows my Linux files. You can see if you click on the address bar that it's using a path that starts with WSL $, which you can also access yourself. So I can just go here, and you'll see all of the running distributions. And you can just go in them and see the entire file system. And from there, I can, of course, just open any file with any Windows tool. So if I want to edit the README in Notepad, I can do that.
Also, we'd like to point out that this is a Linux file-ending file, and Notepad now supports that. So if you look in the top, bottom right.
Yes, Linux file ending is right there.
Linux file-ending.
And this is not just Explorer, obviously. You can do this from any applications, which means you can do some pretty funky stuff with it. For example, I can just list the contents of the distribution from PowerShell, or even do something like look at the proc file system and see the CPU status of the Linux environment. Or, if we want to get really fancy, I can do something like, let's echo some text and redirect that to a device. I actually need to check what TTY this is on. This is on def PTS1. So what I'm doing is I am echoing some text into the sudo terminal that Ubuntu is currently connected to, and you'll actually see it shows up there. So I can write to a device file in Linux from PowerShell. That's pretty cool, I think. Anyway.
A weird world.
Yeah. Anyway, I want to fix that bug. Of course, I could just use Notepad, but there's a much more convenient way. If I run code dot from here, oh, it apparently needs to update.
Cool, so it's actually installing. What we've done is we've run code, and this is not the Linux version of VS Code. So we didn't download and install VS Code inside of this Linux distribution. We have it installed of Windows. And we just saw when it said installing server is we have this thing called the remote extension installed.
Yes. So this is Visual Studio Code running inside of Windows with the remote WSL extension. And you can see in the bottom left here that it says it is connected to WSL and the Ubuntu distribution. What that means is that if I hover over any of the files here, you see their Linux path. This is actually directly reading the files from inside of Linux. It also means that if I build this, well, it's Node.js, so I don't really need to build this. But if you were doing this on a C++ project and you want to build it, it's going to run the Linux compiler. If you execute it, it's going to run it in Linux. So let's see if we can track down that bug. Supposed to select the image here. It's a very tough bug, this. I have no idea what could possibly be causing this problem. I think I need to debug this. This is there's no way I can just see what this is. So let me just set a breakpoint here and start debugging. Likes to get in the way. Now I need to go back to Edge and hit the website. You'll see Visual Studio Code starts flashing because it hit that breakpoint. So right now, my website is running in Linux, in WSL. I just accessed it with the Windows Edge browser, just using localhost, hitting a breakpoint in Visual Studio Code running on Windows. I can see it has detected that we are running on Linux, so that's good. But it steps over that. Oh, I see. The condition is the wrong way around. All right, let's just stop that, fix that. There's no way I would have just seen that. I really needed to debug that. And we can start debugging it again. Refresh it. All right, hits it again, step through, There we go. Now it's selecting the right image. So let's resume that. And there we go.
Perfect. We are production ready.
Yes. So as you can see, this makes it super easy to develop Linux applications that you can deploy to the cloud or use for anything else, matching the exact environment you have on your production servers on your desktop, but still getting all that convenience you're used to from the Microsoft development tools. It is really awesome. Would have saved me so much time in the past if this had existed.
Yeah. And so that's the state of the Windows subsystem for Linux today. Oops. Oh, I see.
Oh, yeah.
Switch back to the slides. So that's the state of the Windows subsystem for Linux today. But obviously, we are working on improvements, and we want to address the top customer asks. And those are increasing the file system performance and increasing the compatibility. We want to be able to run more things, and we want to be able to run them faster. And so that is where we have the Windows subsystem for Linux 2. The goal of this change is to improve those two components, file system performance and compatibility. And so what we mean when we talk about WSL2 versus WSL1, what's the distinction? What we mean exactly is WSL2 only changes the way that your Linux user space binaries are calling into system calls. That's it. The same Linux user space binaries, they are just running on top of a different layer. So that WSL layer is different. That's all we've changed. So when you are using WSL2 versus WSL1, it's just a different way of running in the back end, the architecture behind that.
Most of the time, you probably won't even notice. Actually, all the demos we've done so far were running on WSL2.
Right, and it will look exactly the same as the Windows subsystem for Linux 1 because we've kept the user experience the same. And so when we talk about file system performance, well, how much of a change does it actually make to switch over from WSL1 to WSL2? So here's some speed tests that we did actually on the laptop that we're demoing on. And when we did git clone on the VS Code repo, that was 2.5 times faster than WSL1. When we ran npm install on that same repo, that was 4.7 times faster. And when we ran CMake on the OpenCV project, that was 3.1 times faster. So these are significant performance increases that you're for sure going to see when you switch over. And the other half of this is the full system call compatibility. WSL2 actually has 100% system call compatibility. So that means all of your Linux apps will work inside of it. So what this translates to is things like Node.js, Vue, CMake, C++, Python, whatever Linux application will work. And really importantly, so will Docker. So remember we were running on WSL2 originally. That's why we were able to show Docker inside of the command prompt. Before, when you were running WSL1, you weren't able to use Docker. And Sven is going to be jumping into the architecture changes and why that's the case. But WSL2 unlocks these experiences for you. And let's talk a little more about Docker, because actually we're really, really excited about the opportunities here. Docker is growing significantly in enterprises. We have 40% growth, 15% of hosts, according to Datadog, which is a cloud data analytics software, are using Docker to host their applications, their sites. And that is why we're really excited to be working very closely with the Docker Desktop for Windows team. So this is a screenshot of a post from the blog of the Docker team saying Docker loves WSL2, the future of Docker Desktop for Windows. They've released a tech preview that instead of using the Moby Linux VM, targets WSL2. So if you're not familiar with the architecture behind Docker Desktop for Windows, and that's OK, we have docker.exe. That is the command line interface that you're used to do Docker pull, Docker run inside of PowerShell or CMD. And that calls into a Moby Linux VM. That VM is where the containers are running, and that's the way it's been. What we've changed is change that Moby Linux VM to use WSL2 instead. And that's what the difference is inside of this tech preview. And so now the containers run inside of your WSL2 instance rather than this Moby Linux VM. And so there are tons of immediate benefits for this. The first is, if you've ever had to start up Docker Desktop for Windows, there's a startup time of about 45 seconds. Using Docker Desktop for Windows with the tech preview targeting WSL2, that startup time drops to 5 seconds only, because WSL2 starts up in an instant, as you've seen inside of our demos.
That's a really big difference.
Yes, huge. As well, there's tons of other improvements, including CPU usage, memory allocation, which is really important, as well as network access. And so we're really excited to be able to show this, and I'll be showing you what that looks like live. So we'll jump back on over to our computer.
7.
Yeah, we'll do.
Oh, you're going to do that on that one.
Yeah, we'll do 6. So here I have Docker Desktop, and you can see that under General, we have enabled the experimental WSL2 based engine. So I give that a check mark. Now it will target my WSL2 instances, and I can run my Docker Desktop workflows. And so we already seen some Docker, so I want to show something more exciting, because they've also just released support for Kubernetes as well, running inside of WSL2. So I'm going to open up a Kubernetes app, and we're going to use this new system. So here I have my app. It's running inside of VS Code. I have a very simple example app from the Docker team called the voting app. And this is what it looks like. If I do, let's make this a little cleaner. Docker app install, orchestrator is Kubernetes, and its name is, we'll call it voting. So now this is going to spin up my services. Here we have some different databases talking to each other, to talk to different websites, and this is what it looks like. Oh, let's use the new edge.
And you just ran Docker from inside of PowerShell on Windows.
Yes, so I use the Windows context, but at the end of the day, everything is running inside of WSL2, inside of Linux. So if I go to localhost 5000, you can see I have a simple straw poll here of cats versus dogs. We'll choose cats. Sorry, dog fans. And over here, we'll do localhost 5001, and we have another website that tracks the votes here. So if I go to dogs, it switches over to dogs 100%. I go to cats, it switches over. So this is using Kubernetes to orchestrate these different databases, these different services, and workers to interact with each other, all running directly inside of WSL. So we can actually go take a look at that. If I'm inside of PowerShell, I can run docker image ls, and I can see all of my images. If I run docker ps, I can see what is running inside of my Docker containers. But I can also go to Ubuntu, and let's make sure that we can see it. If I go to WSL integration under resources, we can choose which distros we want to expose this to. This is part of the architecture behind this, is that you can expose it to your different distros. So you can either run the Docker service directly in a distro, or you can choose to expose it through Docker Desktop for Windows. So in here, I can also run docker image ls and see the exact same data that I saw in PowerShell.
And now you're running the Docker client for Linux.
Right, exactly. And so this is the Docker client for Linux. So what's nice about here is if you already have some Docker scripts that run using Linux tools, you can use those. If you have Docker scripts that run using Windows tools, use those. They'll target the same back-end architecture, and they'll work on any machine. And so that's really the goal behind the Windows Subsystem for Linux, is to bring these two worlds together. And that also includes extensions. So I can go and take a look at this Kubernetes extension, and close that. And I can see all of my Docker Desktop. I can see my nodes, my namespaces, all of these services directly from VS Code. So we're really trying to bring these two worlds together as much as we can. And let's jump back over to my other machine, and we'll do a speed performance demo. So let's do it live, and we can see how it looks like to run WSL1 versus WSL2. So I'm going to open up one Windows terminal, and we'll open up another so we can do a side-by-side comparison. So with Windows Terminal, I've set up a custom profile to run WSL1 on the right and WSL2. And so Windows Terminal actually has background images, so that's why we have this cool-looking penguin to help you differentiate between what's running where. And let's clean this view up a little bit. Here, we're going to time sudo apt install Python.
We're giving WSL1 a head start.
Yep. Python. Oh, and we'll do time. Almost forgot. And we'll time it here. And so now we're going to watch them race live. Any bets? WSL2? Got it? And you can see that WSL2 is raced on ahead and finishes in just 11 seconds. WSL1 is still working. And we still love...
Exactly a photo finish.
Yeah, not quite. We still love WSL1, and WSL1's awesome. And you can still use both. we just wanted to highlight some of the differences that you'll see, because how often do you go into your Linux distribution and run sudo apt update, sudo apt upgrade, and sudo apt install? Every day, right? All the time. And so that is where the immediate benefit of running WSL2 comes in. And so this is still going. We'll let it almost finish. The last thing that I want to show you is how you actually install and use WSL2 on your system. Oh, 53 seconds. So that's quite the difference.
Yeah.
Save you a lot of time. So let's take a look at how you actually install that on your machine and run that. I'm going to hop back over to PowerShell. Let's clear this. And I'm going to run WSL list verbose. This will show me all of my WSL distros that I have on my machine, and it will show me the state and the version that they are running in. And so
You could actually run both WSL1 and WSL2 together with different distros.
Right. So that's how I had this Ubuntu WSL1 distro and an Ubuntu WSL2 distro. You can run them side by side, and you can switch them between any version that you like at any point. So to change the version, all I do is run WSL set version, the name of my distro, like Ubuntu, to 1. From here, this command will run. It will change the version over to 1. I can try that out, try that experience. And at any point, I can go back over to 2. So it's really that easy. And you can also set WSL set default version to 2.
You can also specify what version you want to use when you import. So if you don't want to constantly switch back and forth, just export a distribution and then import it back in as the other version, so you can use both of them.
Right. So we wanted to make it as easy as possible to move back and forth so that you can see the differences between the two. Cool. All right. So Sven, how did we do this? What changes did we make to make this possible?
Oh, magic, mostly. OK, yeah. The big question, of course, is how is all of this possible? Well, we already saw this slide before. It is the architecture of WSL1, where we had this translation layer. It's a driver called LXCore that implements the Linux kernel application binary interface, the ABI, and basically intercepts all of the system calls that the unmodified Linux binaries make, and then translate them into something the Windows NT kernel understands. And that was a pretty cool architecture, and it worked pretty well, but it does have some limitations, because Windows and Linux, they do have some differences in certain operations that are very hard to bridge. For example, say you have a directory with a file in it. You want to rename that directory, but the file in it is open. If you do this on Windows, you're going to get an error, because Windows does not let you rename directories if any of the descendants are open. If you were to do the same thing on Linux, that succeeds, because Linux has no problem with this. With WSL1, because we were implementing the Linux behavior on top of Windows, if you were to try this in WSL1, it would fail, which is an obvious difference from how Linux actually behaves. And that is obviously not something that some applications want. This isn't the only example. This is just one. There's others in file systems and other areas. And with WSL1, there also were just areas that we didn't support at all, because, well, Linux is big. It's constantly changing. They're adding cool new stuff. And we, as the WSL team, would have to add that stuff to WSL instead of spending time on making cool features like the file system access or the import-export, and maybe like the enterprise features that people are asking for. So we were thinking, how can we get around that? Well, it turns out the best way to emulate Linux is to use Linux. It's a very weird concept. So what we are doing with WSL2, instead of the translation layer, we switched to a virtualization-based environment using the latest and greatest in virtualization technology developed by Microsoft. And we are actually running a real Linux kernel on top of that virtualization to use WSL2. And that means we get 100% compatibility with Linux, because it is Linux. And it means we can get those speed improvements because we're using like the real Linux file system inside of WSL. So we're using the Linux kernel, but where does that come from? It's actually shipped with Windows. Let me just say that again. We are shipping a Linux kernel with Windows. It is built and managed by Microsoft. We update it for you. It gets updated by Windows Update. It's a very weird sentence. So when there's security updates or anything, you don't have to worry about that. We'll update it for you. It is based on the normal Linux 4.19 source, which is the latest stable branch. We will keep it up to date with the latest stable branch. But it is the real Linux source. You can see it at kernel.org. We didn't change it very much. We have a few patches in there. We tuned it a little bit, which mainly means we changed the configuration, tweaked it so it would run really well on WSL2. So removing devices that we don't need, things of that nature, just so it can start really, really fast.
And all these changes are actually open source and available online at GitHub. So you can go check out WSL2-Linux-kernel, and you can see everything that's there. Check out all our code, commits, watch as we build it.
Yeah, you can see the exact version of the source that we're using, including the configuration that we're using if you want to check that out or build your own kernel based on that. So you might wonder, why are we using virtualization? Well, that's pretty simple. I already said it, because it gives us that perfect compatibility with real Linux and also gives you that improved performance. But you might also wonder, why are we doing this now? Why didn't we start out with this? It seems like the more obvious approach. Well, that's because this wasn't really possible a few years ago. Because what we're using is not just your average VM. What we are using is something called a lightweight utility VM, which is something that's only been available recently. Because we've just made a lot of improvements in virtualization recently, and we are able to use those improvements to power WSL2. So this lightweight utility VM is actually something that we developed for server scenarios, for containers. Normally, if you run a container, they are just processes running on the same machine, isolated by namespaces or something like that. And that means they're really fast to start and stop, and you can run a lot of them on the same machine. But the isolation guarantees between them aren't like super great. So if you're running, like if you're a cloud provider and you're running workloads from both Coke and Pepsi on the same machine, you probably don't want them to just be containers. So the lightweight utility VM was developed to allow containers to run inside of a VM, which we call Hyper-V isolated containers, which gives them the better isolation, while still having a really low overhead, so you can still run a lot of them and still start them really quickly. It's actually something that's already been used on the client, not just for WSL2. You might have seen this in technologies you're familiar with, like Windows Defender Application Guard, which lets you run a browser tab inside of a virtual machine for isolation, and the Windows Sandbox, which gives you an isolated desktop environment if you want to install something and you're not sure what it's going to do to your machine. So where does that put us compared to a traditional virtual machine? Well, if you just set up a VM with Linux, it's going to be isolated. Yeah, you can probably set up some network folder shares or something like that. But that's extra work that you need to do. Whereas in WSL2, you can still just access your Windows file system like you've always been able to. You can still start Windows processes from inside your bash shell and do all those other things. A traditional VM typically takes quite a while to boot, whereas WSL starts in about a second. It is incredibly fast. A VM, you need to set up how much memory it's going to use, typically a couple of gigabytes, whereas WSL2 only uses the memory that it needs. It will grow as it needs more and shrink back as it is no longer needed, and Craig will actually show that in a little bit. And you also don't need to worry about it in WSL2. You don't need to set anything up. You don't need to configure it. You don't need to start it or stop it. WSL2 does all of that behind the scenes. You don't even need to be aware that this thing exists. So with that, our architecture now looks more like this. So instead of having a translation layer sitting on top of the Windows NT kernel, we now have the hypervisor at the bottom. Windows uses a type 1 hypervisor, which means that even the host OS runs on top of the hypervisor. And the Linux lightweight utility VM also runs on top of that hypervisor with that real Linux kernel that we ship and build inside of that. And on top of that are all of your Linux user mode binaries from all of your distributions. And they actually all run in the same VM, which is another advantage there, because if you want to run Ubuntu, Debian, Kali, all these other distributions all at the same time, you still only need the one VM, which saves a lot of resources as well. And the big difference that we want to point out is basically this blue arrow there. That's the communication between the Linux user mode and the Windows user mode. That's what facilitates the file system access, the interop, launching commands, and all the other things that make WSL so seamless to use. Now, I just told you, you don't need to configure any of this, but we're all power users here, right? So, of course, you still can if you really want to. We've always had some options in WSL in the etc wsl.com file, which were per distribution. But since all the distributions run in the same VM, we added a new file in your Windows user profile called .wslconfig. And if you really want to, you can configure the number of processors your VM is using, the amount of memory, the maximum amount of memory it can use. And you can even use a custom kernel if you need some drivers or modules that are not available in the kernel that we provide. Of course, if you do that, it no longer gets updated from Windows Update. It becomes your responsibility. And like I said, you don't need to ever do this. Like, this is purely optional. But if you want to, you can. So now Craig is going to show some of the improvements that I just talked about.
Yep. So here we are back in PowerShell, and we started from a cold start. So this is, everything is shut down. There's no VM running on my system. If I go take a look, there's not much memory usage. We're OK. Cold start. It's just like you started your computer up. And from here, I'm going to run WSL, and we can time how long it will take for it to start the VM, initialize your distro, and give you a bash prompt to start playing around with. So that's 3, 2, 1. 1 Mississippi, there we go. So about a second.
Have you ever seen a normal VM start that fast? I haven't.
No, I have not. And you can take a look here, and we have vmmem has started. So this is the process that's powering our WSL2 distros, and it has about 450 megabytes of memory in use right now. And so that actually uses a small portion of your total memory on your system. And from here, I'm going to jump back out, and let's go to my nice tab where I have my nice themes with Windows Terminal. And I also have another test in here. That's a small C test. What we're doing here is I've written a little C program. It will allocate a lot of memory. And then once we hit enter, it will free that memory back to the system. So this is simulating running a big program, maybe something like a big build that's going to use a lot of memory, be really resource hungry, and then finish it once we hit enter. So once we run that, now it's allocated all that memory on my system. You can see my VM is resource hungry. It's grown to meet the needs of my program. And then once I go back here and I hit enter, the program is over. I can use free-h to see that my used memory has dropped down to 54 megabytes. And our VM memory has dropped right back down. So it will grow and shrink as you use it. It's not something that we want you to worry about or ever really think about because we build it up, tear it down for you, and manage it for you as much as we can. So we're almost out of time, but where can you get this right now? How can you access this, and when will it be generally available? So if you want to use it right now and start playing around with it, start seeing how it can fit inside of your enterprise, you can go to the Windows 10 Insiders program and select the fast ring. From there, it will install a build on your machine. You can start using it right away. You just need to enable WSL and get going. After that, we will be generally releasing WSL2 in the first half of 2020. So in the first half of 2020, it'll become available as part of the Windows release there. And we have a ton of resources for you if you want to learn more about WSL. So please feel free to take a photo. I'll leave it up for you. If you want to stay involved and reach out to us, my name is Craig Lowen. I have my email on the screen, and I'm also on Twitter at Craig A. Lowen. So please reach out to me there if you have any questions. I'm always happy to help.
It's the same for me. If you want to follow me on Twitter, I'm not that active, but you can always ask me questions at SvenGroot_MS.
And then we have tons of links on the side. The command line blog is a great place for all news for Windows Terminal and WSL and anything else command line. Our GitHub issues page is where we personally and the other developers on the team are on the boards constantly to help resolve your issues for WSL. We have a Learn WSL page for anyone who is wanting to get started in this space. Please visit that. We have a course link there that will actually take you through a course of building a Node.js site with WSL. Our docs has all of our technical information. And lastly, we have a Windows Insider link to get you started there. Thank you so much for coming out today. We really appreciate it.